So I want to show you. All right. So last week or last class, last week we talked about XML. Last class we talked about kind of an overview, excuse me, of JSON data, what it is and what it does, and all that jazz. So I want to. Today's actually going to be pretty brief. We'll talk about. Just a couple of quick examples of how you use JSON and C#. And then, excuse me, we'll talk about next project. I want to give you guys a little bit of a, let you guys kind of get some feedback about project idea and stuff. And we'll talk about that in a second. So let me go ahead and share my screen. Okay, so I created it. In the last class, we talked about a person as a data type. We talked about a variety of different things. We had like if they were, married, if they were living or dead, and got a Boolean variable for that, and birth date and first and last name and all that type of stuff. So here is kind of a mock-up, if you would, of a person. Now I have a small change in here. I have is living. I just check to see if death is equal to null or not, which should work, and it actually gives us a little bit of a problem. We'll have to kind of work with that. I'll show you what that problem is momentarily. I have a get name, which is my first and last name with a space. And then if you notice here, I have all my references for first name, and I have a built-in getter and setter for those. So I have them all set to public. I have a date time for birth and death. And then I have a string that is an array of strings, actually, for just a list of the children a person may have. So all that is pretty straightforward, I think. There's nothing that's like, oh my goodness, what are you doing there? I don't see anything like that. Do you? No. Okay, good, great, yay. Okay. All right, so I've got a person and I called it me, and I gave it my name and a birth date. By the way, this is not my birth date, because I don't know who's going to see this video. And so if you're thinking this is a video and like you're going to come in here and like steal my identity, okay. So let's say that I want to, take the person that's me, that's not me, and feel free to steal the person who has a identity similar to me, and you want to go in and create this, if you would, as a JSON string. So there's a couple things that you could do. You could write a method that would be like JSON export, and you could kind of like create your own JSON exporter for it. Or you could do the following. And notice that I have up here using system.text.json, right? So I'm going to create a string JSON, and it's going to equal JSON, and we're going to do JSON serializer. Notice that in my text.json, I've got a bunch of different helper classes and different things that I can do. So I'm going to do JSON serializer dot serialize, and then I'm going to pass it an object. Me. That's my object. System.console dot write line, and there's my JSON string, right? If I go and run this, there's my JSON string. That's how hard it was to create. Does that work for you guys?
That works.
I mean, it goes in and it says, oh, let me take this object and let me take all of its public properties that I have using getters and setters, and I'm going to put it out. And it knows, okay, if you look at it, it has your object here's your little brace and collection of braces. Here's your first name, and it puts the colon and does the first name and it does the last name. So it's got the self documenting. It separates all the fields out by commas. It puts all my stuff in together. And it's just done. And that is the brilliance of using something like JSON, because it is literally that simple. And likewise, if I were to reverse this process, I could say JSON, um, what's I want to say, JSON serializer, and notice that it has a deserialize. If I come up here, I have a deserialize. And what that is that is going to be, I'm going to read in JSON and I'm going to export out an object. So I'll have to do a little bit more work to use the deserializer because I have to cast it as the type object that I want it to be and things like that. But it's still literally like one line of code, assuming you have the objects already created and stuff. And it's going to map what it needs to map, and it's going to ignore what doesn't need to be there. And that's it. You're done. It's literally that simple. So JSON, I think, becomes a lot easier to work with because it's just not as much parse this, get this child, get that child, do weird stuff like that. It's designed as this is how data is stored already. Why are we going to make this difficult? Let's just go ahead and boom, use it. So um, that's really nice. You do notice it has a couple other things which are kind of interesting. Um, Here, where you got the angle brackets, that's going to be for uh, throwing in some other stuff. Like if I got a vector, I got a whole bunch of them. Um, I would deserialize async, which is going to be, if you look at this, it has a system.threading.task. Um, so what this means is this is a asynchronous call. So I can go and make the call and then in its own thread, have it go off and run and do its thing and while I'm over here doing my thing. Um, so that's kind of an interesting little piece um, that I can work with. Um, and I've got some other things in here as well. If I look at my JSON in general, you'll notice I have things like a JSON object, so I can examine the structure without necessarily looking at the values and stuff like that. I have some document options that I can set. I have elements that I can look at and just different things as far as that goes. So it's got a lot of um, helper information that works with it uh, that makes it a lot easier to use. And if I were to go and take PHP and look at PHP and JSON, I've got similar types of things. If I go and look at um, Java and JSON, I once again got similar types of things. So JSON's a little bit easier, in my opinion, to work with. It's a lot easier to work with, a lot simpler, and that's just partly just how it was constructed. Of course, if I'm using it in JavaScript, which is really was really intended for, was for the web browser to talk to a server and say, "Hey, I need some information." Um, so, for example, I might look up uh, currency rates, so I know how to um, swap currencies and do conversion between um, rupees and dollars, or between yen and euros, or between whatever my two that I'm looking at, Australian dollars versus U.S. dollars, because they both call them dollars. you know, Whatever that needs to be, I can look at it and I can get that a little bit easier to work with. Um, Generally, JSON data doesn't tend to be, at least the ones that I've seen, doesn't tend to be like really huge. I've not seen megabytes and megabytes of JSON data. I have seen that with XML data. That's not to say it's not out there. It's just not. I've usually seen it more in a web service thing where you're doing little bits of data at a time. So that's always worth thinking about and mentioning as well, as far as that goes. So that's a good and interesting little piece just kind of throw there in the back of your mind. Um, Outside of that, it's pretty easy. So I want to start talking about actually. Do you guys have any questions on that, or is that like that was a whole lot easier than I was expecting it to be? Wow.
It
Um,
was a lot easier than I was expecting it to be.
it's about as easy or difficult as you thought it was going to be. And
Yeah.
that's the nice thing with having libraries and having established libraries. Um, when I started coding, when I was your guys' age, um, the good and bad of it all was that there weren't as many libraries out there. There weren't any web libraries. You know, uh, when I started in college, there was no public internet. Um, you had some local bulletin board stuff. You had CompuServe, Prodigy. AOL was just starting, like AOL 1.0 type stuff. Um, and if you were on the internet, you had to be attached to either the Department of Defense or a large university. And even then, your access was very limited in what you could do. Um, so we've seen a lot of changes occur between then and even the year 2000, which was only about 6 or 7 years later. There was a huge amount of changes that occurred over the internet, and then the next 10 years was that much more even. It just grew and the capabilities and whatnot exponentially. If anything, we've hit a bit of a plateau, I think, in the last few years. Um, and we're poised to have another kind of runaway breakout type of thing, um, which is going to be interesting. We've seen more work done in the mobile sphere than in the web sphere, um, and we've got to find a good way to merge some of that together. Some mobile devices are using data like XML and JSON to talk back and forth to servers because they you can't store everything on your mobile device. People are expecting information to come from a server and be updated or shared or cross communicated. So how do you do that? JSON becomes a easy way to handle that. And so there's some really good stuff. There's some bad stuff with JSON as well, and it makes it interesting. And the same holds true with XML when I'm talking between server and client. Um, I don't have any checks for to know if my data became corrupted. Um, one of the things I always have to worry about is has my data become corrupted? You know, a simple bit flip here and there changes the whole meaning of a sentence. Um, I might know if I didn't receive all my data, um, but I have no built-in error checking. So that becomes kind of an interesting, like, how do I fix that? Maybe I add a field in there that has, error checking. This is what I'm, dealing with. Um, there's always a way to do stuff like that. So you're having to, for lack of a better term, trust the network to send the full data. Um, and that's a bit of a challenge. Okay. Um, there was another interesting thing, and I was reading up on this. So don't worry about this piece up in here. This is something that's actually known as uh, the game of life. The game of life is kind of a really interesting. Um, I can put game in quotes because it's not something you play. Um, but this was an early uh, prospect into figuring out how does data manage itself and whatnot, um, and can we run simulations? Um, this winds up being um, very simple, uh, and the idea is you start it and you kind of let it go and run, and you have a series of grids, and uh, you have a grid. And it has a series of x, y coordinates, and in each one of those coordinates, you can find a cell, and your cell is either living or dead. If you have too many living cells touching each other, then your cell will die from overpopulation. Um, if your cell is uh, not able to have enough people around it, then it dies from underpopulation. Um, if your cell has is dead but has enough living cells around it, then population explosion occurs essentially, and you get more. Um, or if you have just the right number of people, it stays static, and then it runs through a cycle again and again and again, and it kind of exports out this whole process. So there's a whole series of rules in here, um, and this was kind of created, um, trying to figure out how it would work. Each at each time when it runs through this loop, you can think of this as kind of like a state machine with individual states to determine, if I'm living, I can go to dead, or if I'm living, I can stay living. Um, where if I'm dead, I can go to living, or I can stay dead, and I can kind of figure out how do I move amongst them. Let me see if I have. Ooh, I have a whiteboard. This should work. Okay, let's see if this works. So, in a state machine, I can have a situation here where I have a state. Pretend that's a circle, and I'm alive. I'm living. And I have a circle over here, and this is if I'm dead. So I look at my rules and say, okay, can I go from living to dead? Well, I can if certain rules are met, and I can look at these rules. Um, that allow me to go from being living to dead. I also have rules that allow me to go from living and stay living. I have different sets of rules. Likewise, I have rules if I'm dead, I can stay dead, or I can go from dead to living. This is this is known as a finite state machine. Um, I could be either living or dead. I can't be some, you know, anomalous weird halfway state. There is no zombies in this where you're kind of living but kind of dead. No vampires, no nothing like that. I've only got these two states, and a state machine is really an interesting concept. Um, they were used in early computers, and people went away from them. Um, and now people are going back to them because we realize that they still, even with all this extra processing power and things like that we have, that in some cases it's still very powerful. Um, and it's a very smart way to introduce changes and whatnot. So if I think about, like, for example, microwave, um, I've got an interface that communicates with uh, a simple computer that is going to run my microwave. And based upon this interface, I can look and say, okay, um, if I am in a pause state, I could go to an instruction state. An instruction state is where I'm entering in, and I can enter in things like a time and a power setting, or a um, I could enter in a pre-programmed cook setting. So I'm going to make popcorn or baked potato or thaw meat or whatever. And then from instruction, I can go to cooking. But if I'm cooking, I can only go to back essentially to my pause, or if you prefer, stop state. The idea being is I cannot go from cooking and enter in stuff to change the way I'm cooking while I'm cooking. Likewise, I can't go from pause straight to cooking. I've got to be pause and go to enter into my instructional state where I'm going to tell it what to do. The way I move from instruction to cooking is I press the start button, right? So I've got rules involved with this to determine from what state I go from here to here. Um, and this is known as a finite state machine. Um, I took 2 semesters of dealing with this when I was at UCF. I had such a wonderful instructor in this, and it was they called it discrete structures. That it took me a semester and a half to figure out what a discrete structure was. Uh, so great instructor. I was being a bit facetious, but you know, I've got rules that I can see here and follow along that allow me to move from one state to another. Um, and I might have multiple rules. So, like to go from cooking back to my pause state, it could be uh, my timer goes to 0. It could be I hit a cancel button, whatever. So, knowing how these states work and know I can reference myself or I can only go from one to another, that's all kind of up um, to what your system requirements are. So what I would like to do for a final project and just be thinking about this is and we might take these rules and kind of maybe do some modifications on them for lack of a better term, but setting up um, a system that allows us to build out something like this and we can track the progress of it and how it moves and doesn't move and stuff like that. We don't necessarily have to follow these specific um, rules and ideas and whatnot. This is done a wide variety of things. You can see here some different examples of ways that things move over time if things are set up. Um, it's kind of an interesting process. So we could figure out um, do we want to hard create some stuff or do we want to um, just uh, have randomization, what type of randomization occurs, um, and just kind of figure out from those types of things. So if you want to, you can read this. This is it's called Conway's Game of Life. Conway was the person who came up with this. John Conway. He actually just passed away um, this past week. So it's the reason why it was come up, and I said, "Oh, let's think about this and how we can do this." One of the interesting ways and possibly to look at is taking this, excuse me, and um, more complex versions of this go in and are used by sociologists to determine can societies survive on themselves or do we run into problems? Um, and people often go, "Oh no, this is okay," and you'll get economists that go one way and sociologists go another way, and medical people go another way and stuff like that. Um, we're seeing right now in very large cities, of course, with the virus spreading, places like New York City, which is a very large city by U.S. standards, is having some really bad problems with it, partially because of its size, uh, and that can cause an imbalance to from overpopulation to start to occur. On the other hand, you can get into a situation where you have a small city, and if you got a city of 1,000 people or something, and it spreads through a situation like that, the whole city could disappear and become a ghost town because you don't have enough people to support it. You need a certain amount of support um, to have a city be able to grow and survive as well. So, there's some interesting things that come out of this. whole process. This is just a really simple one that you can kind of look at. So I would recommend looking at this and thinking about this, um, how you can reference it and process it, um, and then we can look at um, how we'll actually start building it and how you want to either set up initialization sections, or other types of things um, to work with. So we'll look at that if that's okay with you guys. Any questions? Any questions for our whiteboard before I erase it?
No.
Okay. All right. Go ahead and close that out. All right. Okay. So, I guess when I was doing the whiteboard, you saw the whiteboard and not the rest of the screen. Oops. Sorry about that. I'm still learning this. That's my excuse. Screen. Okay. So here's the whole thing. Conway's Game of Life. Um, and this actually does a pretty good job about showing you all the different, or not all the different examples, but some of the different examples that you can look at, and how you want to do that. Okay. So any questions on? I've got to write this up. I haven't had a chance to write this up yet. I'll be working on that today or tomorrow, or something like that. Any questions on that or JSON data or anything of the sort? Okay. Well, if you guys don't have any questions on that or the JSON or XML data or anything like that, I think we'll call it a day. A little bit early, let you guys grab some lunch if you hadn't had lunch yet, or grab second lunch if you're a hobbit. You know,
Or if you're grabbing breakfast.
grab breakfast. I couldn't survive having breakfast at 1 o'clock. I have to eat early.
Yeah, I've just completely thrown off my whole sleep schedule.
Yeah, it's crazy. So
Like this whole thing, it's like I feel like I'm supposed to be at school, but I'm not. And then when I'm home, I'm just doing things that I do at home, and it makes me feel like I'm supposed to not have school. And then everything's all thrown off because I remember I have schoolwork and I'm doing other things that I just regularly do.
yeah,
It's like
so
it's just weird.
yeah. Oh, I get it.
Like,
Um,
yeah,
we should be. I think all the grades and stuff are in. If you see anything missing, let me know. Um, but I think everything's all caught up as far as that goes. I think I finally got all caught up with all my assignments um, yesterday or this morning, actually. Um, trying to get everything straightened out and yeah, like you said, what am I supposed to do at home versus school versus I find myself just I'm doing about 3 times as much schoolwork. It feels like it's actually only about 50% more, but there's a lot of stuff that goes on with that. So, all right, well, I will have office hours tomorrow. If you guys do have questions, um, we will be working also on. Let me just pull up, make sure I'm not missing anything. Um, Calculating password complexity, which is actually very simple. Believe it or not, that's a simple thing. So that'll give you guys some time to work on the project, um, and then we'll look at the regular expressions, which is not as simple, and then we'll
great.
go from there. So um, anyway, that should give you plenty of time to work on that stuff. Okay.
All right.
All right. Thank you all for coming. I appreciate it. I will see you guys next week
All
on
righty.
Monday.
See ya.
If you have time, can I ask questions about the senior project?
Sure.
Okay,
Let
so I
me.
tried to do the trigger, but it didn't like it.